for those of you guys who are triple, you also need to know about Le Chatelier's principle. And the most common reaction you're going to see here is nitrogen plus hydrogen makes ammonia. Of course, this is a reversible reaction. And remember that this reaction between nitrogen and hydrogen to make ammonia is called the Haber process. And it requires relatively high temperatures, high pressure, and a catalyst, which is usually iron. And remember that according to Le Chatelier's principle, the position of equilibrium, which is kind of where the reaction favors, can be changed by changing the conditions of that reaction. And let's remember these rules. So for temperature, when we increase the temperature of a reaction, the equilibrium will shift to the endothermic side of the reaction. And for this reaction, which is the Haber process, the forward reaction is exothermic, which you'd be told in the exam, and the backwards reaction is endothermic. So if we increase the temperature of the reaction, it's going to shift to the endothermic side, which is the reactant side. So this is where we need to make some compromises. We don't want the temperature to be too high, otherwise all we'll make is nitrogen and hydrogen, but we don't want it to be too low, otherwise we won't even reach the activation energy and the reaction will occur too slowly. Which is why we need a relatively high temperature, but you should be able to explain it like I just have. Now when it comes to pressure, Le Chatelier's principle states that when we increase the pressure, the reaction, or the equilibrium rather, will shift to the side with fewer moles. And if we look at the reaction again, we can see that the product side has fewer moles, because there are 3 moles of hydrogen, 1 mole of nitrogen, that's 4 moles in total, and that makes 2 moles of ammonia. So there are 2 moles in total on the product side. So therefore in the Haber process, we want a very high pressure. But again, we need to compromise, because if we use a pressure which is way too high, this is going to cost a lot of money and we're going to need to get very expensive equipment, and that might not then make the ammonia worth making anymore. And the last factor which can change the position of equilibrium is the concentration. And if we increase the concentration of the reactants, the reaction is going to try and counteract that by increasing the reaction of the products. So we can say it's helpful to increase the concentration of the reactants, because that will shift the equilibrium to the product side and therefore create more products. And finally, with this Haber process, I want you to remember that having a catalyst present, which is an iron catalyst in the Haber process, does not shift the equilibrium anywhere. However, the presence of a catalyst will increase the rates of both the forwards and the backwards reaction, therefore increasing the rate of reaction overall, without changing the position of the equilibrium.